As promised, let's expatiate on step 1, which is stating the hypothesis. So when it comes to the hypothesis, there's what we call the null hypothesis, and there's also what we call the alternative hypothesis. The null hypothesis, that's H naught. The alternative, that's HA. What the researcher intends to reject is what we call null hypothesis. What the researcher wants to fail to reject is what we call alternative hypothesis. Please note my words, intends to reject, but the researcher might end up not rejecting it. What the researcher wants to fail to reject, but the researcher might end up not failing to reject it. So it's also worth noting that the null hypothesis and the alternative hypothesis are mutually exclusive. So to better understand what is going on, let's give an example. If a researcher believes that the average age of students at Wale-Kesh learning is greater than 30 years. So that's the researcher's belief. So the researcher believe that the average age of students at Wale-Kesh learning is greater than 30 years. So that's the researcher's belief, and this is what the researcher intends to fail to reject. But the researcher might end up not failing to reject it. So what's the mutually exclusive event here? The mutually exclusive event is X bar is less than or equal to 30 years. So that's the mutually exclusive event. Since the researcher believes that everyone at Wale-Kesh no one can be 30, they are greater than 30 years, maybe 31, maybe 32, 33, and so on. That means the mutually exclusive event will start from 30 downwards. It's also worth noting that when you are stating your null hypothesis, it must have an equals to sign. It must have an equal to sign. So you must state your null hypothesis in a way that it will have an equal to sign. And your alternative should never have an equal to sign. So that we are all on the same page. Example of stating a null that will have an equal to sign is this. We can see less than or equal to, or it could even be X bar is equals to 0 or is equals to 30. This is an example of a null hypothesis. But for alternative, it should never have an equal to sign. There is no equal to sign here, or it could be something of this nature. X bar is not equal to 30 years. So I'm sure this makes sense to us. So this should make sense to us. So I want to believe we can move on. So let's look at one-tailed test and two-tailed test. One-tailed test is a one-sided or a unidirectional hypothesis test. To better understand what is going on, a researcher believes that the average returns, that's X bar, that will be alternative because that's the researcher's belief. The researcher's belief is always the alternative, that the average returns on stock M is greater than 10%. First thing first, just as a quick revision, since there is no equal to sign, even if you are not told, you know we are dealing with an alternative hypothesis. But we're interested in the fact that this statement is a one-tailed test. So to better explain this, so I've written this 10 out here. So the researcher believes that the return upon investing on this stock on the average should be greater than 10%. So you can see that it is one-sided. The movement is just towards one direction. The researcher does not believe that the stock can be lower than 10%. So the researcher believes that the stock price on the average should be greater than 10%. That's one-sided. But a two-sided or a two-tailed test is a two-sided or bidirectional hypothesis test. So a researcher believes that the average returns on stock M is not 10%. So that we are all on the same page, let me draw the same diagram. This is 10%. So if it is not 10, that's X bar. So alternative is saying X bar is not equals to 10%. So it could be greater than 10% or it could be less than 10%. We can see that it is two-sided, but it is not 10%. Unlike this, that the side was just one-sided based on the researcher's belief. But what we have here is a two-sided test, which simply means we are dealing with a two-tailed test.